Hello guys, good evening, welcome to the session. Yes. In this session, we will talk about Snowflake, not like entire Snowflake. We will discuss about two features in Snowflake called streams and tasks. To focus on the streams and tasks, we have taken a use case. We will generate some IoT data and we will see how we can stream that IoT data. We will perform some tasks on that data. First of all, let us talk about Snowflake a bit. Okay. These term Snowflake or this particular service, recent times we are hearing a lot. So what actually is this Snowflake, guys? Have you ever used any products like AWS, Azure, or GCP? Is the Snowflake is also same like them, like other clouds, or is there any different thing in Snowflake? Any idea about this? Okay, let us talk briefly about Snowflake. See, this is a cloud actually, but not like the other clouds which are popular in the market like AWS, Azure, and GCP. It is a cloud which hosts platform which allows you to create your data lakes, data warehouses, you can run pipelines. What is interesting about this cloud is it runs on top of AWS, Azure, and GCP clouds. Yes, it creates a hybrid environment. With minimum efforts, you can create a hybrid environment. Actually, the interesting part about Snowflake or the USP of Snowflake is they are separating the storage layer and compute layer. Of course, here we let us say there will be cloud service layer. Now let us take an example of cloud AWS. They host everything. They have lot of services that are available, on demand in the market. They are enterprise level clouds, and we know that. If you take AWS as an example, they manage the storage, they manage the compute. Suppose you want to create a data warehouse or a database, you will go and create that service from AWS. They will assign you, they'll provide you a storage, and they'll take care of compute, and they'll also take care how to bring that virtually to you. That is cloud service layer. Actually, the service is hosted somewhere else, not on our premises, on the cloud. Virtually bringing that to us, that is cloud service layer. One job of cloud service layer that AWS will take care. Not only that, they manage the storage, they manage the compute, the processors or the servers, and also the storage. And you can virtually connect and do your work. Whenever you want to scale up, you can scale the storage, you can scale the compute as well. Okay, this is good. Let us say your organization is finding this entire stack on AWS a bit expensive. They want some other provider where they can run, build a data warehouse as a storage solution on storages like S3, which are object storages. In AWS, we have S3. In Azure, we have Blob. In GCP, we have GCS, Blob and GCS. So what are these? These are called as object storages. They can store any kind of data, just like Google Drive. If you are very new, I'm going very brief about these things. Uh, they are like Google Drive storage. Forget about the software Google is providing, like spreadsheets, photos, and other things. If you remove that, if you talk about your Google Drive as a storage, what it is, it's not like a database. You can store anything in your Google Drive, right? Photos, videos, any kind of stuff, CSV files, they are structured. And then text document, it's unstructured. You can save anything into your Google Drive. These storages are like that. Let us say organizations saving lots of data in these. And they feel if there is a storage solution which can organize their data from the storage itself, directly from the storage without moving this to anywhere else, then they can save upon the cost, time, and efforts. So that's where these Snowflake came and it became popular. Even these cloud providers are also providing services which does that. But you have another option, Snowflake, comparatively bit cheaper also. So what this Snowflake's idea is, organizations or people who are using either S3 or Blob from Microsoft Azure or GCS from Google Cloud Storage, if you have your data on this, you have terabytes, petabytes of data here. You're bringing in all the real-time data here. You have your batch data here. But you are finding any other alternative as a data warehouse, finally. You don't want an in-house service from this, but your storage is in-house in AWS, Azure, and GCP. But eventually you will clean this data and you'll put it in data warehouse. You don't want that data warehouse from these cloud providers. In such scenarios, you can make use of Snowflake. Actually, Snowflake builds on top of these storage solutions. You can choose your S3 bucket or a blob storage or GCS as your storage. Snowflake also has an inbuilt storage, but they also have an external storage. So the main USP is their external storage. You can bring in your storage from these clouds. And the compute part. You have some 20 GB file here in S3. You have attached Snowflake to this S3. Now you can bring in that 20 GB file to Snowflake and you can compute here. Compute in the sense you can check the data quality. If any null values are there, you can fix them. If any mismatch of data types, you can fix them. Machine learning related pre-processing, all are available in Snowflake. You do the compute. Once the compute is done, you can save your data in the data warehouse of Snowflake. Right? Again, where is this data warehouse storage based out of? Your S3 only. And you don't want to, for some reason, you want to bring in data to Snowflake, but you don't want to compute right now. You just want to save your raw data. You have two more options, something called stage and something called database are available in Snowflake. You don't know the schema of the file. You don't know anything about the file. You have to analyze it and then transform it. Then straight away bring your data to stage. It's a CSV file or a JSON file or a text document. Straight away you can store it in stage, like in its raw format. No, you want to write that file into database, that is rows and columns. In tables, you have database. Here you don't spend your time in analyzing and pre-processing your data. Later, once all your data comes into stage or database, you transform your data. And the transformed or clean data, finally, you can save in data warehouse. So Snowflake offers all these. It offers stages to save your raw data. It offers databases so that you can put your data as tables. And all these are available not in the Snowflake. You can have your data in S3, Blob, and GCS. You can connect Snowflake and you can directly use your data from there. So that is the interesting part. And then you also have a data warehouse on Snowflake. Finally, all the process data you can save in data warehouse, all the data. That is about Snowflake, guys. That is like short intro to Snowflake. And Snowflake has improved a lot. It started like that. It has a lot of features to handle structured data, semi-structured data, and unstructured data. And as we discussed, Snowflake has 3 places where you can bring in data. One is stage. You can save your data as it is in form of files, flat files, like CSV, JSON, and so on. Or if you want to save your data as tables, we have databases. You can save as tables. And you want to save your data as tables, and you want to make some analysis of that data, and you want a huge platform where you can save all of your data, you have data warehouse. Not only these 3 places, storage platforms, Snowflake also provides us compute platforms, independent virtual machines or servers they manage to do the computations on the data. Okay, today we will bring in semi-structured data, JSON data, that is IoT data. As we discussed, from where we are bringing this data? In S3, AWS S3, not to Snowflake directly. As we discussed, Snowflake has ability of building its data warehouses, databases, stages on top of these cloud object storages. We will choose one of the cloud, AWS. First, we will bring in data to AWS, IoT data. From AWS, we will see how to create an integration with Snowflake. As data comes in, this is real-time data, right? As data comes in, we will talk about 2 features of Snowflakes called stream and task. And then task. Stream is nothing, bringing the continuous data, and task are the operations which we are going to perform on that data. Okay, let us look into the use case picture or architecture, and we'll come back, discuss the terminology, streams, tasks, etc. Okay, this is the flow Sorry, guys, some power fluctuation. Okay, back to our presentation. I have changed a bit here. I have changed it from subscription to Snowflake now. That is not required. Okay, this is our flow. What are we going to do? We are going to generate some data which we are assuming as IoT data. That data will come into here, S3 bucket, which is object storage. And as data comes here, we will create something called Snowflake integration. So with this Snowflake integration, we can bring the data from S3 to Snowflake. To where? To stage or database. Just now we talked, right? Three places are there where you can bring in. You can bring in stage if you want to bring in as it is. Suppose if a file is CSV file or a JSON file, flat file, a text file, flat file, you can bring into stage first and then write into the database. Suppose if it is continuous data, then you can directly put it in database. Any of these places we can bring in data. All the IoT data once it reaches the Snowflake. From here, we will create something called a snow pipe. So the snow pipe, it is a continuous, what we say, moving of data. For this use case, IoT data will be continuously coming. It will be ingested into the Snowflake. As soon as data comes into the Snowflake, stage or database, in any of these platforms, you can send your data. Databases are ideal. In short, what I'm trying to say is new IoT data comes into AWS S3 bucket, and that will be moved to Snowflake database. As soon as a new entry comes into Snowflake database, Snowpipe using their stream will get that data. So seamlessly, you can achieve something called as CDC here. Change data capture. Whenever there is a new update or a new row inserted in the database, we are interested in that. Snowpipe is one feature of the Snowflake. They can get that. So you will create a stream. First, you will bring your data into the database. You will create a stream in the Snowpipe. And not all the data, only the latest data. Once you set up, only the latest data will be fetched by the stream. See, initially the raw data fetched, Snowpipe loads into a new file, into the raw table. And then stream detects the new rows, only new rows. And only on the new rows, you can run the tasks. Like you want to, since it's IoT data, you want to check some sensor value. Let's say temperature sensor. If temperature sensor is greater than 40, you want to create an alert. You want to just put another column and say it's an alert, red alert, something like that. Aggregations, continuous data is coming. Rather than keeping everything as it is, you want to aggregate, summarize sensor values for every 5 minutes and then write into your data warehouse. Finally, we will put in data warehouse. Sorry, guys, bad handwriting. And it's also not proper. Okay. So different use cases you can you can apply this pipeline to different use cases. For example, location data is coming. A vehicle is sending location data to the S3 bucket, and we are not interested when a vehicle is sending the same location. It sends this data every second. So first we will bring in all the data. from S3 to the stage or database, and Snowpipe reads all the data. It streams all the data and then detects. See, stream speciality here is it detects the neuros only. And if there is no change of neuros also having the same location data, then you can just summarize that and then you write in the data warehouse rather than logging everything in the data warehouse. So things like that, different use cases, different data will have different requirements. And you can apply this pipeline and seamlessly build CDC pipelines. These kind of pipelines are called as CDC pipelines. You can also add one more word here, event-driven. Event-driven CDC pipelines. Why? This snow pipe will be triggered. It will run only when event occurs. What is that event? Data comes into the database and it will fetch the new data. So this is like a event-driven CDC pipeline. Okay, let us start building it. Enough of theory. Before going to the deployment part, any doubts, guys? You can ask or you can type in chat window. Right. So there are some prerequisites I should mention before starting this. Of course, the accounts. For this, we are choosing S3 bucket. That means we should have AWS account. If you want your data to choose from Azure Blob or GCS, you need respective cloud accounts. And you will bring in data to Snowflake, so you need Snowflake account. Okay, these two things. And in AWS, we have to do some what we say provisions so that it can seamlessly integrate with Snowflake. We will also talk about that. These two are mandatory, of course, it's obvious. You need AWS account and Snowflake account. Once you set up those things, I'll first go to my AWS account over here. Just give me a minute. Why my system is not, yeah, now it opened. Okay, this is my AWS console. It's loading. Yes, this is the AWS console. The first thing I have to do before starting generating the data, sending the data is, I should go to this place called IAM. Identity and access management is very crucial part in AWS, especially when you are integrating with the external factors and also internally when you want to move your data from one service to another service. IAM plays crucial role. What it does, it ensures that the safety metrics with right authentication, proper identity, services or people have to connect with AWS. That is the objective of the IAM. Now here, data is coming into the AWS and from there, Snowflake has to take the data. So obviously, security should be taken care here. How we can do that, we will look into that first. First, you should go to roles and create a role. And here you have to select something called custom trust policy. See, this custom trust policy, you have to write in JSON. For that, you should go through Snowflake documentation. You will come to know how to make use of this for Snowflake custom trust policy. See, the name itself says custom trust policy. So you are doing some customization to trust some external entities. In our case, that external entity is Snowflake. So you have to create this custom trust policy. I have already created one. I'll just take you there. IAM. Yes, leave, continue. Roles, Snowflake S3 access role. Okay, here, roles. When you want to grant permissions to programs, to people, or to external entities, you will create a role. Before granting that permission, first we should create a trust policy, trust relationship. We will look into that. Trust relationship. You can just click on edit trust policy, or just now I have shown, right? You can directly go to roles page, create role. Here you have custom trust policy. You can select that and create your custom trust policy. Anyways, you can do that. Going back to the policy. Yes, here, trust relationships first, because Snowflake is an external entity